All right, let's get rolling. So, first thing is, this will be your last warning. Don't forget to upload your files by 10 if you didn't do so already. And from here on out, I'm not going to hold your hand on that. So, figure that out. This thing's going to kill me here. All right. So I forgot to tell you yesterday on that tutorial, that kind of jumps you into SolidWorks really quick. Don't expect you to fully understand everything that's going on there. It was just kind of a introduction, just show you some stuff in SolidWorks. So don't worry if you didn't really understand why you were doing things or how you were using certain functions. It was just kind of an intro. We'll go into it in more detail in the lessons here. Today we are starting our split groups, so I hope you remember who's A and who's B. So we'll all be together in here for the first segment, and then we'll split up. I think I'll send the A kids over with Professor Hodgkinson. That'll be in Lockheed Martin room, which is ECAE 1B16. So off this main hallway, you head west, and it'll be a double door on the right, 1B16. And then for the third segment, we'll swap. So the A kids will come back here, and the B kids will go over there. And he's gonna, let's see, we're gonna have a take-home quiz today, and 2 homeworks assigned, and 2 videos assigned. So that's coming up. I'll go into more detail on that. All right. Any burning questions about the course or whatever we did yesterday or homeworks last night? Okay. All right. Why don't you pull up SolidWorks? We're going to continue where we left off yesterday. So go ahead and pull up SolidWorks. Draw yourself a rectangular prism. You can make it any length, width, height you want. It could be metric or inches, doesn't matter. And what we're going to end up doing is I want you to make a extruded cut in there. And we're going to make it such that that extruded cut, no matter how we change the dimensions of the rectangle, that extruded cut will be centered in the vertical dimension, but not necessarily the horizontal dimension. So I'll show you how to do that, but for right now, make yourself up a rectangular prism in any size, length, width, height, and make an extruded cut all the way through that prism. A circular extruded cut. Byron, how'd you do on the cards and ITL stuff? Get anywhere?
Yeah, I'm on my process of getting the card one figured out too.
How about ITL?
I was kind of confused about that.
So what you have to do is you just gotta go to the ITL level app and then
talked to a guy named Kai, and he runs a tool here. And I don't know which ITO I like walked there and there was a lot of labs.
Why don't you
I can show
why don't you yeah, you could either do that or you could wait till tomorrow. We're doing Kai's actually going to give a lecture tomorrow. So I will go over and beg and plead with him to do a special tour tomorrow and get you an account. He's an old Arrow alumni, so maybe he'll cut you some slack. All right, we all there? So if you'll remember from yesterday, if we dimension from the sides to the center, then those are hard and fast rules. And when we make this rectangular prism longer or wider, it'll still stay that far away from those edges. We want to make this thing centered, at least in the vertical dimension. So the way you can do that is you can add a rule to this circle, and we'll do that using relations. So you need to get back to your sketch for that circle, for that cut extrude. So I'm going to edit that sketch. I'm going to go to display, delete relations, and hit an add relation. And what I want to do is take the center of this circle, and I want to get a midpoint on this line, because midpoint would center. So I'm hovering across this line, and I can't really find a midpoint. So I'm going to get out of this relation. I'm going to go ahead and add myself one. So I'm going to go to the sketch tools and select point. And I'm just going to put a point, and you can see that Solidworks snaps it onto the midpoint. And you see it added a relation for that point. It said, okay, that point is the midpoint. All right, now I can go to display, delete relations, add a relation, and I've got that point and then this center point, and I want to make them, so I'm not 100% sure whether it's horizontal or vertical because my piece is kind of twisted. So I'm going to change my display view so I'm looking at it normal to this plane. And now it's clear that I want that vertical. So I'll make that vertical. You can see the circle moves. I'm going to accept that and then exit the sketch. All right, now to test this little theory, let's go back to this boss extrude. I'll go to this sketch. I'll edit it. And I've got this at 8 inches. Let's make it 20. And exit the sketch, and you can see that that circle stayed centered. So if my design intent was to always have that circle centered in this long dimension, then I can force it to be that way using relations. If you go back, so since we did not relate the horizontal dimension, if I change this 2.5 to 6 inches, that little circle guy is not going to move. It's still going to stay up there at the edge. So how would we force that one to be centered? add a relation. So we'll jump back to that sketch for that cut extrude, and we need a point on the midpoint of one of these lines, and then we need to add a relation between that point and the center of that circle and make it horizontal this time. We'll accept that, exit that sketch, and now it doesn't matter what we do to the dimensions of that rectangle, that circle is going to stay in the middle of that rectangle no matter what we do. Okay? Any questions there? Make sense? So once again, and I know it sounds like I'm beating a dead horse, but this is really important, this design intent stuff. In aerospace, we teach systems engineering, a top-down approach. So we start with our base problem and we break it up into much smaller pieces, and we write requirements on this system. And then we design based on those requirements. So back to the coding idea, you're starting with your base problem and you're thinking about how you'd like to attack that, the structure and architecture with which you're going to solve that problem before you actually solve it. So if you're making a pretty big model, you should think about that to begin with. Break your major problem up into smaller problems and determine how you would attack it and how you want things to react when you make changes, because you will make changes, no question. All right, I'm going to assign the Solidworks final project today and explain it. So part of that, I'm going to tease a little bit here. Part of that final project will be an animation. So I want to show you an animation. This was from a senior project 2 years ago, an excellent senior project. They created a system that would, a camera and a laser ranger and a feedback control loop that would take a, kind of looked like a trash can. And down at the Lockheed Martin Waterton Canyon facility south of us, they have this huge robotic lab, a 6 degree of freedom lab. And you can attach whatever you want to the end of this 6 degree of freedom robot, and it simulates space. So you can hang an object somewhere in the room, which simulated, in this case, they were looking at orbiting space debris. And they wanted to go capture it, go grab it with this big trash can thing. But they needed a system that could find that trash, recognize it, and then as this robot is moving through space, it could keep it tracked and send the robot commands. Hey, the object's over there, and it's this far away. Start moving that way. And then at a certain frequency, it would update that information until it tracked it. So to do that, they had to make a system, and I'm going to show you the video of what the Solidworks model video of how this system works. Now I could talk to you until I'm blue in the face. I could open up the Solidworks model and talk to you until I'm blue in the face about how this thing works, but a movie does it so much better. So here you see this camera. Here you see a laser ranger. You've got a 2 degree of freedom gimbal system that they designed and built, actuated by servos. And some related bearings, brackets, screws, etc. This thing was so cool. Geez, I should have brought you the video. I don't know if I have it. I probably don't have it. Within the facility itself, this huge robot used this system and it went and captured this piece of garbage. It was cool. I should have brought that. I'm sorry. So animations are really critical when you're trying to explain a high-level concept to a group. In aerospace senior projects, it's not exactly required, but everybody does it. Everybody has an animation. So you're going to be required to do an animation, and that'll get you set up for your senior year senior projects. And especially mechanicals, I don't even know if they require that stuff. So if you do one, you'll look awesome. So you're gonna have to do that. So I thought I'd just tease it. All right, back to sketching. Let's do some more sketching. I'm gonna close this guy out. New part. I want you to sketch a piece of pie, or like a Pac-Man, or the big O and the missing piece. Did you ever read that book? I want you to sketch up a circle, and then make a little pie piece in there. So you want to go a line from the center, then make sure that you're touching the circle edge. Then see how I'm still in the line function, but I don't want that line there, so I'm going to escape out of the line function. Now I've got a radius in there, and I want to put another line in there, another radius, just like that. So kind of a Pac-Man eating a piece of pie. Trivial Pursuit, I don't know. There's a lot of things that looks like. All right, again, blue, underdefined. I've got automatic relations that Solidworks just jammed in there. You can see them here. If you want to display them, you hit your relations manager. So I've got a coincident with, looks like the origin. I've got a coincident with what? What is that coincident with? So if you hover over that coincident, it's coincident with the arc, right? The circle. So it says coincident, arc, and point. So the point's on the arc. But yeah, the circle. And then there's another one right here. So those rules prevent me from moving in certain degrees of freedom. So if I drag this line, I can drag this radius, but that coincident rule restricts my endpoints. The one endpoint has to stay at the center, the other endpoint has to stay on the arc. Same here. If I were to try and move the center of the circle, I can't because I'm of that coincident with the origin. If I wanted to move the whole circle, I could take that coincident with the origin and get rid of it, and then I could probably move the whole circle. Oops, I got to get out of my relations. So now I can move the center point of that circle away from the origin, right? But still I have to maintain these coincidents here. And I know we're going into this in excruciating detail, but I'm telling you, it's a million times important because all your errors are going to be due to relations or dimensions when you rebuild these big assemblies that you have, and you're going to have to go figure out where they are. So I kind of want to break this down for you. Okay. Let's dimension the angle. So smart dimension this angle. Let's make him 75 degrees. Notice when I was tapping that, I can type 75. It kind of guessed I wanted degrees. I can type the degrees in if I want to, or I can pull that drop down and make it radians or something else. All right, so there's my 75 degrees. I'm going to escape my dimension tool. Notice my arrow has the little dimension symbol. So that tells you what function I'm kind of in. I want to escape that to get out of it. And then I can start dragging again. Same thing happens. I want you to go back and add that relation of that point being coincident with the origin. So the center point, the origin, force it to be coincident again since we deleted it. And then I want you to drag. So check this out. I can drag the circle into a bunch of different shapes, but that little pie piece stays the same. It always has to be 75 degrees. Let's add another relation. Let's make one of the radii horizontal. Add relation, pick a radius, make it horizontal. Notice that my pie piece went black, so it's fully defined. So I cannot move this now because this angle has to be 75 degrees and this has to be horizontal. There's nowhere I can move it and still satisfy those rules. But what could I do?
Flip it.
I could flip it and I could make the circle bigger, right?
Yeah.
Cool. All right, now I'm going to add a relation to make the other radius vertical. Let's make that vertical. What's going to happen? It's going to be unhappy. Sketches over. I love Solidworks when you get a problem, man. It hits you with 20 things. So you got down here, you got overdefined. Click here to resolve. You've got item is unsolvable. It's red and it tells you which one is unsolvable, and that's that vertical relation. You've got item conflicts in yellow. That's this one. You've got existing relations. It says this vertical is the one that's hurting you here, and that's historical. You can click here to resolve it, and then you can hit this diagnose button. It's kind of cool, and it's going to give you all the options it thinks would solve the problem, and sometimes that helps. So here it's got 3 solutions, so let's go through them. It says showing solution 1 of 3, so it's saying get rid of this vertical relation. That makes sense. What about the next one? It says get rid of this angle, and then it even shows you what will happen. If you get rid of that angle, you could make this horizontal and vertical, and it'd still work. That's cool. And then 3 is get rid of this horizontal, and then your 75 is still there, and your vertical is still there. So sometimes SolidWorks is helpful with giving you some ideas. Sometimes it's not. So I just wanted to show you that dialogue. As you get more complicated, SolidWorks has more and more trouble figuring out ways to help you. So this is a pretty simple example, so it could figure it out. But sometimes SolidWorks will even just say, hey man, we don't even have any ideas. Good luck. So in that case, it's kind of hit the undo. Back up. So let's just pick one. Let's hit this accept, and that got rid of that horizontal, and now it's cool. All right, we're going to talk about some other sketching stuff, and most of this is going to be in the context of machining. Okay, so I know you haven't seen SolidCam yet or machining yet, but just pay attention. You're going to have to remember this. You can always go back to this video. Out of curiosity, did anybody go back and look at the videos for some reference? Yeah? Okay, cool. So that helps. Cool. All right. We're going to do some other sketch stuff. So let's sketch another line. Let's do another radius. But let's say you kind of went out last night and you're not feeling so well, and you missed the circle, and you just kind of oops. You just kind of did an oops. All right. What if you wanted to deal with this? Now there's multiple ways to deal with it. You could just drag this thing and drop it on the circle, and then it'll drop that coincident. But you could also trim it. So I want to show you this trim tool, and there's a little drop down. You can either trim or you can extend. In this case, I want to trim. So I'll hit trim entities. And then there's a whole bunch of options. There's a power trim, there's a corner. We don't have a corner. Trim away the inside, trim away the outside, or trim to closest. Let's try trim to closest. And just, if you hover over this thing, it'll kind of, you see the little scissors on the tool? If you hover over it, you can kind of see a preview of what it's going to do. It's going to take, see, it highlights just that line with the orange. You could also hover on the inside. It would take that inside one away. But you can trim that guy, and now you have a line there. So those trim tools are kind of useful, especially if you have a more complicated sketch and you just want to get going. You can just jam in a whole bunch of lines and then trim them away, rather than trying to be real careful with your lines. So sometimes that speeds things up. Questions about that trim function there? All right. Let's do this offset entities function. This is kind of cool too. Let's say I wanted to make a kind of an annular cylinder. I could just pick that circle and make an offset by, let's say, 1/4 inch. You see that? And it dropped in another circle 1/4 inch away. So that's kind of a cool tool sometimes. We will go into mirror later. And we could do sketch patterns. Let's do that later. All right. Okay, this one's huge. And this one is tricky in that Solidworks hid it from you. They didn't want you to know. I guess most people don't use it, but in machining, it is extraordinarily common that we would like to break, say, this circle right here up into pieces. Just for clarity, I'm going to delete this circle, and I'm going to delete this radius, and I'm even going to delete this dimension just so that you can see. What if we wanted to machine Pac-Man here? We actually wanted to machine Pac-Man. Now, when you get into machining, the problem with machining is, unlike CAD drafting, you actually, to cut this thing, something or somebody has to hold this sucker down while you're cutting it. So we have to clamp this thing down. So how can I clamp a circle and machine all the way around it? I can't do it. I would cut through my clamps. Can you envision that? If I had a clamp, you know, there holding this thing down, and I have a clamp holding it down here, I can't machine around this whole piece. So one common technique that we use is, what if I was to just machine from right about here to right about there, and then one at a time remove the clamps, put it over here, and then move this clamp and put it over here, and then I'm free to machine the rest of it. That's an extremely common technique in machining. You're going to have to use it in this class, and if you build anything in your projects courses. Did you know as an electrical you can take our course, our senior projects course?
For aerospace?
Mm-hmm.
Did not know that.
Mechanical has their own you have your own projects courses too, but they tend to be extremely electrical because you don't have a machine shop.
Yeah.
So a lot of EEs like to take aerospace courses to. I mean, you're going to do the same thing. You're going to do electrical stuff and probably some coding, but you'll actually get to put it on a really pretty cool piece of hardware because we build cool stuff. Anyway, just throwing out a little plug. Just throwing out a plug. I will tell you it's hard. Our course is really hard, but cool stuff. The projects are cool. All right, so we want to break this circle into pieces so that we can see if I hover over it here, it hovers over the whole thing, turns the whole thing orange. I want to break it into a couple of pieces. Well, that's not in my sketch tools here. All right. Now there's a couple of ways that you can find this sketch tool. First, you could click the circle, and then you can right click, and SolidWorks tries to guess all the associated things that you would like to do with this circle. Now if you go down about halfway or a little farther, you can see this split entities tool. All right. Another way to find that is to go to tools. I don't know why SolidWorks always dogs down on tools. But if you go to tools and you go to sketch tools, now you get every single sketch tool under the sun here because you haven't selected the circle. So it doesn't pare all the options down for you. This is every tool under the sun. But you can see it's there. You can see some other cool stuff too. Fillets, chamfers, mirrors, stretching entities. You can see a bunch of other stuff. But sketch picture, we'll be going into that tomorrow. But you see the split entities tool. So let's pick that. And it really, because this is CAD CAM, wants you to understand split entities because we need it for machining. So you'll look at the little pencil thing, and it's got the little split entities tool, and then it says click on the sketch entity to split. So I click on my circle, and it puts a little point there. And then I click on my circle again, and it puts another point there. Now if you hover over the circle, you'll see it made this part orange. And then if I hover over this part, it's orange. So it split the circle at those 2 points. But that's not what I wanted. I wanted to machine the Pac-Man. So what I can do is I can close out of that. But it put those little points there. Okay? Now I can take that point and I can hold, click, and drag it down to my Pac-Man point. And then I can do the same on this point over here. And now if I hover over, I've got Pac-Man and I've got his breakfast. Okay? This becomes extraordinarily important when we go into SolidCAM and machining so that we can move clamps around our pieces. Questions there? Cool. All right. Another tease for you. Speaking of cool projects, we've had a project in our department for 15 years to design and build a completely student-built hybrid rocket. That means liquid and solid. And the original intent was to get a 10-kilogram payload to 10 kilometers. Did you see what I did there with the metric units? You like that? We developed the motor and a bunch of other systems for years and years and years. And they finally tried to launch this year. So I'm going to show you some stuff related to that. The first thing I'm going to show you is their assembly. This was from last year. They updated it a little bit. I should have got their new files, but I don't have them right now. But this is their assembly. So just as an example of how powerful Solidworks can be, this is their rocket. Now, I will start showing you some piece parts in here, but I want to show you reality too. There's the real thing. You can see the scale by the people in there. So there it is. And hey, do what I say. Hey. And there it is in CAD. A little bit different because it's not the final model, but it's really important to do good modeling so that you can actually build things and they come out right. If we look at this rocket, this is an assembly file. You can see on your feature tree manager, you can click components and can't really see them all that well. They're highlighting blue if you can see. So there's a fin, there's a payload section, and if you open that up, you can see some mates will go into that. All right, and then you can also see display states. So I could hide components or make components transparent. So let's say I want to hide this payload section. I'll right click and hide it, and you can see under this hide display state, see how that thing went a little bit grayed out. So now I can see what's hidden. Want to show you some of the plumbing of this thing just because it's interesting. So in this case, I'll change the transparency. So I can still see that skin panel, but it's transparent. And then maybe let's hide this one. So here's some plumbing. This was the motor down here. You've got a valve in here that turns and allows the oxidizer to flow in. The oxidizer tank, if I right click hide, is right here. Now I'll show you a couple of videos. First one I'm going to show you is a static test fire from last year, which was April 2014. This was a successful fire with it bolted down. Ignition, and they actuate the valve. Ain't gonna get that in electrical time. But we needed at least 3 EEs on that project to get that done. So that was a successful fire. Because of that, we were brimming with confidence. So we attempted an actual launch this year. A little ahead of schedule. So I will show you that, if I can find it. Oops.
See smoke?
Better.
Good.
You'll see up here, we had a chamber breach. You'll see in a minute when the dust clears. Right here. So we didn't develop enough thrust to get off the stand.
We got fire coming out of the top of the combustion chamber, it looks like.
Blew off some panels.
So that was kind of sad.
The pan
But I show you all that to show you the power of Solidworks, and in the future Solid Cam, that helps you to put together a pretty good rocket. Cool stuff. All right, so a little tease. I also want to show you mates. So you'll learn this in some of your videos, but an assembly is made up of multiple components, and you mate them together. You put them together in certain ways. So let's go to a component, maybe this guy. This is the nozzle. And you can open him up, and you should be able to see mates on this guy. He may not have any mates. Let's find somebody that's got mates. Something we can see. How about right here? So this is the top half of the injection housing, and they've got a mate here that's called a distance. And I'm going to close the display states and pull this feature tree manager open so you can read better. Come on. So it's got the fuel assembly and the oxidizer tank assembly are mated with a distance. So they said, hey, we want the face of the fuel, or the face of this component, and the face of that tank assembly. I can't see where that is. It looks like it's down here. Oh, I see. I think it's in here. Yep. I think it's right there. And they wanted it to be a specific distance away from each other, and that distance is here, 0.3. So they're forcing this part and this part to be 0.3 apart. That's the way they designed it. That's how they want it. So that's a mate. You'll see that. You can also, in an assembly, you can click a component and hit open part, and it'll pull that part open. There's that part by itself. It's got some threads, got some O-ring grooves.
Are the O-ring grooves added individually?
Are they what?
Added individually?
Well, let's find out. So you should be able to go to your feature tree manager and figure out every single feature that was put on here. So I'm hovering over this, and it looks like that's going to be that feature, right? So I'm going to go ahead and look at that sketch. And I'm going to look at it this way. So what does it look like they did there with this sketch?
That they had a complete cylinder, and then they made a box sketch to remove certain parts and then revolved it around.
Yep. So on a round part, a real common technique on your features is to use this revolved cut. So you can just spin a cut all the way around. And the tool, imagine ladies that make cakes. They have little tools and they have a little spinny thing and they bring the tool up. Sometimes they're like a comb or something and it makes ridges in there. It's the same thing here. So they used this sketch of these O-ring grooves here, and then they just spun it. And how do you think they would have had to tell Solidworks to spin it? What else would they need to spin that? A central axis. That's probably this guy right here, eh? So you can figure that out by going to the feature itself and editing the feature. Well, lo and behold, there it is, an axis right there, and an amount of degrees, 360 all the way around. So there it is. So yeah, it was one feature, which happened to be a sketch. Now you could have done it a different way. You could have done one cut, you know. There's a lot of different ways to get places on SolidWorks. Try and do the easiest one. All right. Couple more minutes for break. I don't know if I want to sneak this in. I don't think I do want to sneak this in. Questions so far? Really important, sketches. We're going to do a little bit more sketching today and tomorrow, and then we're pretty much done with sketching. So make sure you understand sketching. It's the most important part of SolidWorks. Any other questions?
Is there a way that you can center an object?
How so?
Like at the XY axis? Say that you drew a random square,
Mm-hmm.
and it's not completely at the center. Is there a way to center that?
The center of what? Of the three-dimensional space that is SolidWorks?
Yeah.
Yeah, I mean the only thing that SolidWorks has is a kind of a fake origin in space.
Mm-hmm.
It doesn't. There really isn't a global coordinate system set for SolidWorks. They've got kind of an origin, but they don't really care. So the only way to center it is you can when you make your first sketch. See, SolidWorks has this kind of quasi origin. That origin really isn't referenced to anything. It's just in some crazy place in space. So are you saying I make a square? So to make it square, I'm going to have to, let's say I wanted it 2 point.
Be an equal dimension piece.
That's right. I could add a relation and say that all these guys have to be equal, right?
Mm.
All right, so there's a square, and you're just saying center it on this.
Yeah, so you had like a pole right in the center.
Yeah, you could pull it, and SolidWorks might guess that. But just like our circle from earlier, you could also put a point on the midpoints of the two edges, and then add your vertical relation and your horizontal relation. Make sense?
Yeah.
So I've got too many points selected here. That's why it freaked out. So I need to get rid of one of these points. I think it's 6. You can see the little 5 here and the little 6 here, and it should work. 0.5 vertical. It's not happy. I'll have to figure that out. I'll figure that out. All right, break time. A group meet in 1B16 at 10:05 Professor Hodgkinson will be checking you for attendance, so walk by the room before you go back. B group will meet back here 10:05.